How do you handle heteroscedasticity? Well, there are quite a number of ways of dealing with them. First of all, remember that it can occur because you have misspecified the model. Let's assume that a model is a Cobb-Douglas production function, and you do not specify the logarithms well. Then you will have an issue. So one way you have to now do is to transform the model and then apply logarithm to the model. That is one way. So that you can make the error homoskedastic. Now sometimes there are some variables that were relevant, but you omitted them. Like maybe there was a variable that is called variable X, and that variable was supposed to be incorporated, but you didn't collect that data for it. And so in that case, you will be punished with a heteroskedastic error. How do you deal with it if you have the problem? How do you deal with a situation like that? Well, ladies and gentlemen, there are 3 ways, and it's beautiful ways, by the way. These are enjoyable ways of dealing with that. One is to transform the entire data set. I'll go through that. Another is to use the weighted least square GLS or feasible GLS. I will go through that. And the other one is by using the white robust standard error. I will go through that. So, how do you deal with the situation? Transforming the model. How do you deal with that? Let's look at the first one. How to transform the model. Now, transformation of the model might imply that you have to bring some logarithms. So you are now going to move from level model to log of the dependent variable. So you take the natural log of the dependent variable. And these are some of the examples I'm going to be working it out with you right here. So the first one, if you can remember, when we were doing the first one, we did not take the log of the quantity demanded. But one way you can do this is by taking the log of the quantity demanded. Now, my good friend, this is where you are doing what we call try and error. To satisfy the situation, this is where we do the try and error and see the one that is best for you. So you take the natural log of the quantity demanded alone. You don't log the dependent variables. So it is called log level model. Log level because the dependent variable is logged, and then dependent variables are levels. They are not logs. How do you do that? I'll show you. The next one is to log the dependent variable. You take the natural log of the dependent variable, and then you will log some or all of the independent variable, depending on which one you do. Now, you don't have to be logging by heart. If you start logging by heart, some of the variables will start even getting piggy. And so, you have to, again, you might probably want to take the log of the income and see the results. If you don't like it, you take the log of the C, see the results. If you don't like it, you take the log of the P. If you don't, I have done that, and I realized that taking the log of the income was better for me than the log of the P and C. And when I say better for me, what I mean is the significance of this. So you can take the log of M and the rest will all be significant. But you can take the log of P and then the C and the M will no longer be significant. And so that is what it means. This is called log level log model. So some of the variables are logged on the dependent, and then the independent, some are still level, some are logged. The last one is loglog, where all of the variables, you take the log of everything. Everybody has to be logged. Okay, you take the log of all the variables. So we are going to try one by one. Okay, so let's go to our R to go and then demonstrate this logarithmic situation. So this is our R, and let me just squeeze this slightly and then you can see the results here. So the first one is, and I'm going to show you how to convert the thing into logs. So the first one is, you have your model, and I decided to just make P log. So in the data set called gen, I want to convert the p variables into log. I'll show you how it looks like. Okay. By the way, whenever you want to see the data on the top right here, on that top right, you will see the data set, and you will get to know which of them you are actually dealing with. So I'm looking for gen data. Okay. Let me just go to gen. So the moment I click this, the data set will show at the top of my screen. So you can see that the quantity demanded is showing here, still inside the arrow. The price is showing, the complement price is showing there. The income is showing. Okay. The location is showing, the occupation is showing, and then the religion is also showing. So you have all of that inside the data. Now, what we are going to do is I'm going to create a column and call it what? The log of P. So you can see that the log of P is up here. Okay. The log of P is up there. But we are going to create a data known as the log of P. So that's what we're going to do. Now, how do you do that? There's a command in R that can do that beautifully for us. So I'm going to go to my date, okay, and this is a command, and I'm sure you can see it. Let me just take it up a bit. So the command says gen $log P. So I want you to create the log of P inside the data called gen, okay, and call it log P. Call it log P. So I type log into bracket gen P. This is the one I'm going to make. Run this command. And when you run this command, at the bottom, you will see the name of the console. Now, how do you know that it has been added to the data set? How would you know that it's been added to the data set? So you go to the data set, and now let's go and see the gen again. Okay. You start looking for the gen. That's it. And then in this data set, look on the far right column. You will notice that a new column has been created called log of P. So the prices were 16, 13, 15, 13, 16.5 and all of that. Now these are the log 2.77, 2.56, 2.71, 2.6 and all of that. We've created a log of the P. Now that you've created a log of the P, let's go to the command window. So now we go to command number 240. This command number 240 is a new model we are going to run. This time, not using the P, if you can see there, we are not using the P, but we're rather using what? The log of P now. So you type it, and we change the name. It's no longer gen multi, but we are calling it gen multilog. And the summary, we are calling it gen multilog as well. And so you take this command, and then you run this command in R, and then you see the results that will happen. Now, normally, what happens is that whilst you are showing this, the beautiful thing is that you're going to get your results. Okay, you're going to get your results, and you do those other try and errors, and you get other results, and you check the R square. So if you are ready, I'm going to run these results, and I've just done that. So I'm going to just scoop up to see the results. Now, you can see that in these results, in the log of P, P is not significant. It is only significant at 10% here. Complement price is significant, and it's indeed significant at 1%. Okay, it's significant at 1%. The M is not significant, the log N is not significant, all the others are significant. Okay, so now you would not understand this better unless I juxtapose that with the previous one. So I'll use a table to show that, but this is an indication. What has happened to the R square? Look at the R square, it's 0.9881. Now, if you just want to look at the previous R square, let me just go up and then look at the previous R square. Okay. Look at it. In the previous R square, P was still only significant at 10% and all that. The previous R square was 0.9884. So look at it, 884. So R square, it was 884. Now here R square is 881. So you can see that this transformation did not help us in any particular way. So that means that we need to go to the next level of transformation. Okay. And by the way, those are the results that you might get. And so after you've done this, there are two things you do. After you've done the formulation, you can check the R square, which I just did, and then you can also check the Pagan test on this again. So you can see that in my command 242, I decided to do the Pagan test again on this multilog. Let me run that and look down here. It is still showing that there is heteroscedasticity. Okay. Now I know that this wasn't going to work, but I had to still do it for you guys to know that that is the situation. The next thing is to do the log linear form. So this time, I'd rather give the dependent variable the log. Now remember, in the previous one, if you check it carefully on command number 240, the dependent variable was kill. It was not log of kill. So I'm going to create another situation for the dependent variable. This time I'm going to log it. Okay, so this is a command. Gen $log kill should be equal to log of kill, which is inside the data set called gen. So you create the log of kill. Let's run that. And the moment you run that, it will be added to the data sheet. How do we know? Go to the data set here. And now you can see that another column, which is known as log of kill, has been added to the data set. You see the other column? Previously, there was a log of P that we created. Now we created a log of Q. And the values are different because if you look at number 4, observation number 4, okay, the observation number 4 is higher. And that is the one with a higher log. Okay. Observation number 1, you can see that the Q was 160. So the log is 5.08. But this one, it was 220. So the log is 5.39. Okay. And then you can see that 140 is smaller than 160. So the log of that is not even above 5. It's 4.9. So that log has been created. Now let's go back to our command. Now that we created the log of kill, what should we do? Well, you come to the command here and now take that log of kill. So in this, when I'm going to rerun the whole data set, I'll do log of kill. Okay. And I will call it gen multi-log linear. That's how I'm going to call it, gen multi-log linear. I'll run that and then I'll look at the results. Okay, so this is it. And this is the results down here. Oh. This is the results here. Now, beautiful. Look at the beauty that is showing here. Okay. Some things are really, really beautiful from the little I'm seeing, but some things are also quite strange, slightly. Okay. Whatever it is, the most interesting thing that you see here is check the R square. You see that the R square is not 98, it's now 99. So that's pure 99%. It's 99. The R square has improved by taking the log of the dependent variable. Every other thing is significant. Every other thing is significant. Okay? Whether it's 5%, 1%, or whatever, it is still significant. Everything is significant. Okay? However, if you look at the estimate, okay, if you look at the estimate, you will notice that the estimates, okay, have reduced. Okay, price is negative, complement price is negative, income is negative, okay, Religion, Christian is still negative. However, you see that the values, the actual values are reduced. But the interesting thing is that they are all negative. So you are having a diversity of results, which is good. Which is good. Okay. Now, one thing you can do here is that you can calculate the Pagan test on this. You can choose that you're going to calculate the Pagan test on this. And so with this GMulti, command number 248, I'm trying to calculate the Pagan to check the heteroscedasticity now. Watch it. It is still showing a p-value of what? Almost 0. So again, it still shows that there is heteroscedasticity. So that was a log linear form. The next one is a log. Remember, all of them are log. The dependent variable is log, and one of the independent variable is also log. Okay. Now, I already have the log of the Q, and I already have the log of the P. So I'm going to now run the two of them. So in this command number 255 here, you will notice that I'm calling it GMulti loglog. GMulti loglog. And when you look at the dependent variable, it's a log 1. When you look at the independent variable, it's also a log 1 for the price. So you have those ones, all of them as logged. Now, how do you do that? Let's run the results and see. And this is the results. Of course, if you go and check it in the data, you see. So once again, this one is telling us that everything is significant. Okay. And the R square is also gone up slightly, but the estimates are reduced. Okay. So you have this log model. Okay. And you can do the Pagan test for the log. The Pagan test for the log is showing again 0 p-value. 0 p-value. Okay. That means there are zeros. There are 5 zeros before the 8229. So once again, it is showing heteroscedasticity. Now the last one is I log everything. You create a log of everybody. So that means that those who have not taken the log, I have to add them. Remember, look at the data. Let me take you back to the data. In the data, you have the log of the P and you have the log of the Q. You have them. So I'm going to create the log of the other variables there, okay, just so that we can have a feel of the whole data set. When I finish, I put it all together, then you feel it. So I'm creating the log of the C. I've added that. I'm creating the log of the M. I've added that. Okay. I did it for the, I can't do for the dummy variables. Remember, location, occupation, religion. I can't do those dummy variables. Okay. We are taking the log of the numerical variables, not the dummy variables. So all the independent variables that are numerical, I've taken the log M, log C, log P, and the dependent variable itself, I've taken the log. Now I'm going to run the entire regression. And this is the result for the regression. Now in this results, you can see that the estimates are still lower. The independent variables, not all of them are significant. So this again, and the R square is reduced. So this again shows that taking all of the logs is not the best. Okay. Let's check the Pagan results to see whether there is heteroscedasticity. It is still showing 0 p-value. So once again, it was not that helpful. But again, based on this, you can see that one of the models has helped really, really big time. One particular model has worked well. Okay, which one? You can remember that one of the models seems to have worked well when we put it all together. And I will believe that, please note, in some of the models, the log work best. In some of the models, the log works. Some of the models, taking the log of the dependent variable alone is enough. In some of the models, taking the dependent variable and one of the independent variable is enough. Okay. But it's been found out that this one, this log, taking the dependent variable and one of the independent variable works the most. So what we've done is that we've been able to check. And now transformation has been something that we have used. It doesn't mean that it's been able to solve the problem, but one of the transformations seems to be dealing with the problem for us. One of the transformations, let me take you back here. One of the transformations seems to be dealing with a problem for us. And all of the ones I did are in the slides. You can check every single one of them. These are all of them. Every single one of them. They are all here. Okay. So we've been able to try and handle this whole heteroscedasticity. We've been able to use transformation to see whether there is heteroscedasticity. It might not be so fully clear now until you put all the... So sometimes it's nice to put the data together and let the author know the work you went through, the effort you even put in to do those things. It is important to let the author be aware of what you have done. The next thing now is to use another means to handle the heteroscedasticity. Okay? And we'll come to that.